Hey there, YouTube squad. No bike riding today, just a leisurely stroll. So, I'm going to take a moment here to allow folks to realize the stream is live. And in the meantime, gonna fill up the bird feeder. So, I will be right back. So, don't go nowhere and press the share button and leave us a comment and let us know you've tuned in. Be right back. Give me 2 minutes. All right, YouTube. The camera's crooked, and I'm back. Thanks for tuning in, all 5 of you. And yeah, congratulations on realizing the channel exists. Just filling up the bird feeder here, and we'll talk space weather. We've had some interesting space weather activity, and of course some interesting Earth weather activity too, with 2 hurricanes planted off the coast of South Carolina, Georgia, wherever it happens to be. It's a conflagration of weather. So a very rare occurrence seeing 2 hurricanes at the same time like that parked off the coast. They are expected to depart shortly, those lows, and head off to, where are they headed off to? England or something? Something. All right, so yeah, let me relocate here. James T. Kirk approves. Do you approve, James T. Kirk? He approves. Ricky and Bubbles approve as well. All right, so yeah, just going to relocate here. Pardon my guerrilla filming technique. For some reason, YouTube likes portrait mode streams. I think there's a way to simul stream in both portrait and landscape mode. I got to figure that out. I saw something about something. I saw somebody doing something with some type of thing. So, yeah, let me get into disaster area number 8 of 9. Got to switch tripods here, folks. Got to switch tripods. Second one's not really a tripod. So what's going on? You got any news stories? If you got news stories, let us know in the comments. We'll consider talking about them. All right. Yeah, so I went for a leisurely stroll, no bike ride today. Chilling. And I think it's time to convert the desk. So again, bear with me. I will convert my sitting desk into a standing one. And I'll get to those comments in just a minute. Yeah, the tiki, the fish was the first one I showed, James T. Kirk. He's a pleco, which is a type of South American catfish. He is made entirely out of spikes and rocks. If you stepped on him, you'd probably hurt your foot. The other two, Ricky and Bubbles, they are goldfish. James T. Kirk is, he turns 9 years old this year, and Ricky and Bubbles, they turned 3. They're about 2.5 right now. They turn 3 next May or something like that, I think. All right, so let's talk space weather. We've had some, so that's always good. We like seeing space weather occurring. It's always a delight. And we're promoting an event. Yeah, promoting an event in October. So welcome to October. Congratulations, you've survived another month. And yeah, October will have some interesting activities. One of them will be the pink dress hash. So if you want to see what I look like in a pink dress, it's happening. Some people already know, but just got the final piece of kit. Yesterday was drop shipped. And so yeah, we actually have a very high likelihood of solar flares. In fact, there's a big event happening right now in the southwestern limb of the closest star. So we've also got some new rebranding stuff going on. If you check the Red Bubble Shop, link in the description, you'll find the new 2026 branding. We've already got that squared away. So, you know, preparation is good. So yeah, pseudoscience propaganda is bad and prepping is good. So of course that's the basis for so many sports, right? If you're prepared, the events present themselves to you very nicely. All right, so we've got a sunspot number of like 200 nearly. Oh, it's come down a little bit. Okay, so some sunspots have either set or degraded. The 10.7 is still really high here at 188 solar flux units. Solar wind, we've seen some elevated solar wind, and it looks like a coronal hole high-speed stream to me because we saw the density come up, and then the density dropped off, and then the speed came up. You know, as the density is dropping down here around about 3 protons per cubic centimeter, solar wind velocity came up from about 400 kilometers per second to where it is now at more like 700 kilometers per second. So yeah, it looks exactly like a coronal hole high-speed stream to me. And at the beginning of it, it was accompanied by some quite strong magnetic fields. So we had a total field of 17 nanotesla with a BZ, that's the vertical component of the magnetic field. BZ was negative 17. And yeah, that was enough to create a G3 class geomagnetic storm there. KP 7.33 is where it got to there. So a significant geomagnetic storm, but it was short-lived, and since then it's been dying off. Also, we're going to come out of geomagnetic unrest here in the next update. So really, probably, maybe even before the stream ends, expect to be back down to a KP3 or so. KP 3.6. That's my guess. So yeah, the geomagnetic unrest conditions are likely ending here. We do have a very high likelihood of solar energetic particle events. So people on polar flights and astronauts could be exposed to additional radiation today as a result of the likelihood of proton events. Again, they are very likely as we have an active setting region in the southwest. And it's actually doing things right now. So we could see protons arrive at any moment. Sometimes they show up as fast as in 20 minutes or so. So those are some very fast particles when they show up that fast. The current flare that we have going on is not quite an M class. It's about a C8 class flare. It looks like it is now dissipating. There is likely going to be a coronal mass ejection 2 associated with that flare in the southeastern limb. It will probably miss Earth well to the southwest, as it is quite close to the limb. So when you have a CME on the center of the solar disk, it's very likely to hit Earth. as it dissipates, as it leaves the corona, trying to fill the empty space as nature tries to reach static equilibrium. As far as filaments, we do have some large filaments on the Earth side of the disk, and we did have some significant CMEs. The one from yesterday may have an earthly directed component. I've got to actually check on that. So let me consult the ISWA page. I'll show you the stereo A imagery. We don't show that on every video, but we'll show it on this one because it may show an Earth-directed CME from early this morning, late yesterday. So the majority of it will miss to the southwest, but some may strike Earth. All right, let me get the. Hey, you just passed your grade 10. Congratulations on passing grade 10, Judd Riley and friends. Hi, devil. All right, so let me just, I'm going to take a look at Stereo A. Stereo A Core 2 Space Weather Beacon. That is Stereo A's coronagraph. And let's see what we have here. Anything interesting? No, not really. It looks like that CME is going to miss Earth. Oh, no, wait, we don't have all the data yet. All right, so the major CME from the CME that popped off yesterday around, what time was it? Yesterday around midday, there was a big CME out of the southwest. That's not going to strike Earth. That is well off to Earth's southwest. It's even off to Stereo A's southwest. So it's basically due west of Earth. It's way off to the west. But as far as, I think there is a second one. Let me consult the LASCO C2 and C3 again here. I looked at them earlier, and maybe there was only one CME there. All right, let's see. Okay, yeah, so no earthly directed CMEs at the moment. Earth is solidly in a North Pole sector. We do have a high likelihood of large flares as well as coronal mass ejections. The likelihood that they're earthly directed is kind of low because of the location of the sunspots likely to produce the large flares and coronal mass ejections. And just a quick reminder, folks, don't conflate the two. Solar flares and coronal mass ejections are separate events. I mean, we feel like a broken record, all of we space weather enthusiasts who are talking about this, because it's a constant thing. People think, or they say that a flare is, they conflate a CME with a flare. And coronal mass ejections are not flares. Coronal mass ejections are plasma. Like you see this area here, you can see this, that's a coronal mass ejection happening as we make the video. And that will be not likely having an earthly directed component either. It'll be off to Earth's west most likely, but that is a CME, okay? When you see a brightening, especially in 94 or 131 angstroms, here's 131 since we showed you 94. So there's 131, and when you see a brightening in these wavelengths, that is a flare, because a flare is X-rays. So don't conflate solar flares with coronal mass ejections. They're very different things, all right? Think of it like this. So a solar flare is X-rays, right? What is that? What's an X-ray? Does anybody know? Can you tell me in the comments what an X-ray is? It's a type of ionizing electromagnetic radiation, all right? So it's a form of light. It's very high frequency light, unlike this flashlight, okay? This is visible light. But think of a solar flare like this, because a solar flare is photons. And a coronal mass ejection, think of it like this, because it's protons. You see, it's diffuse gas blowing out of the sun's corona. That's a coronal mass ejection, not even close to the same thing as a solar flare. Solar flares happen all the time with no coronal mass ejection. Coronal mass ejections happen all the time with no solar flare. So that should be, that should really be a clip. So we're making it into a clip. Yeah. So in any case, I just wanted to, briefly mention that because people constantly do it, and there's no flares happen all the time without coronal mass ejections. Coronal mass ejections happen all the time without flares. There's no way to say, oh, a flare was this big, therefore the coronal mass ejection is going to be like this, because again, they're separate phenomena. They are often related, because the plasma orients itself to the magnetic field lines. So while the plasma does have its own magnetic field as well, it's doing that by orbiting the magnetic field lines that come out of the sun. Some of them are closed, like in a sunspot, closed magnetic field lines. Some of them are open, like in a coronal hole. And of course, the particles are then following those field lines all the way out into space. That's what the coronal hole high-speed wind is. All right, anyway, yes, correct. The light takes 8 minutes, approximately. So anyway, that's space weather. Now I'm going to briefly talk about Earth weather here because of those hurricanes. So now the first thing I want to show is how I forecasted that these would fizzle. I said that not only are they going to not strike the U.S., they're going to get beaten up by dust. And look at the Saharan dust. They're completely entrained. All right, so we're going to zoom in a little bit here. That is the DoX on nullschool.net. Now we're going to switch to the pressure, because a great way to look at hurricane. Now this is the surface winds, all right? And we do have some major ones here. These look like they're over 100 miles an hour. But you see the way this is all disoriented? It's all disorganized. You see the way the lows, there are like 1, 2, 3, 4. There are like 5 lows there that are all kind of stretched out. This is because of the dust entraining the convection and sort of tamping it down. So that's the surface winds. But let's take a look at the MSLP, the mean sea level pressure. So there, that's really how you measure a hurricane. Now this one's got stronger winds, but the pressure looks higher. So the pressure there is only, it's not really that low. It's 983 hectopascals. And this one down here that one is also 983 hectopascals. So it looks more organized, but this one has much stronger winds. So that's what's going on. As far as jet stream disturbances, here's the 250. That's the 250 hectopascals pressure. You can see there are some significant kinks in the jet stream. So this will show you the jet stream. This is a portion of the pressure bands. So you can see the jet stream. It looks like there's a suction happening here because we've got a very strong jet stream flow. Zoom out a little bit. You see this jet stream flow up here? This is very, very strong jet stream flow. And this is going to create suction behind it. And you can see those storms are getting attracted to this. Right now, the winds there are blowing 174 knots. So 200-mile-an-hour winds right here at the jet stream level. So, that's going to sort of shear these things apart. And, these are not nurturing forces for these storms. Now, let's see what else can we show here. One of the very important things to look at is sea surface temperature. And you'll actually see some anomalously hot water here. So the U.S. East Coast has got quite a bit of anomalously warm water. Right here it's, let's see, 6.5 degrees Fahrenheit above normal. And that's 83 degrees there. So right here, 82 degrees. There should be a lot of convection happening there, but that Saharan dust really does make a difference. And it entrained these storms early. So anyway, I just figured I would cover that because that's something that people aren't looking at very much. Just as a bonus feature here, I'm going to show just the GFS forecast. In fact, let's show the water vapor map because this should look quite nice. So here's the water vapor map. We'll actually zoom in on that area there to show you how the water vapor is moving. Because keep in mind, folks, this is not visible to the naked eye, right? You only see water vapor that's condensed onto clouds or water droplets. So This is going to show you the dry parts of the atmosphere and the moist parts. So this dry air down here, this dry mass of air in between Florida and this southern storm is pushing it. Also, the jet stream is going to be sucking it up to the northeast. So it's a beat up storm, and this one's getting pressed from the north as well. So it's getting entrained because this dry massive air up here, this dry air is more massive than moist air, folks. So while the moist air, these lows, do control what we call weather, these high nitrogen zones here, where there's a lot less water in the atmosphere, they represent more massive air. And this air up here is cold as well. As you see, it's coming down from Canada. So that's also not conducive to convection. So that's what's going on with the storms. You know, there are a lot of people out there who rely on models in order to quote forecast and quote. And guess what? That's because they're not forecasting. So if you don't understand the physics, you can't forecast. But if you do, you certainly can, and we hope you do too. So thanks for tuning in, folks. It's time to close this thing out. We'll see you soon here at the Smash News Network, the busted name of news. I've been your host, Dan, aka Smash-O-Mash. And until next time, may that solar and hurricane wind be at your back. Hey, thanks for the comment, dunce. All right, anyway, I just thought I'd let the stream run for a minute so you can see that CME as it happens. And it's time to close this thing out. So see you soon here at the Smash News Network, These Busted Name and News. Don't forget to check the other videos. There's plenty of evergreen content.